Question 1. Which of the following distribution of probability of a random variable is probability distribution? We have four options of every x and probability, that is A, B, and C and D. If we check, we know that the sum of all the probabilities in the probability distribution is always unity. So we're gonna check by adding all the probabilities of all the option. We check for A, that is 0.3, 0.2, 0.4 and 0.1, which is 3 plus 2 5, 5 plus 4 1, 1 plus 1 is 10, so it is 1.0. So we can say that 1 is the option correct answer, that is A is the correct answer. We check for B also, that is 0.1, 0.7 and 0.4. We get as 2.1. For C, we check as 0.5, 0.5, 0.2, 0.3. We get as 10, 12, 15, that is 1.5. For D, 0.2, 0.2, 0.2 and 0.5, that is 1.1. So answer A is the correct answer. Question 2. The random variable x has the following probability distribution. For x 0, 1, 2 and 3, and the probability is given as k, 3k, 5k and 2k, k. Then the value of p x is greater than equal to 2 is, we have four options: A 1 by 3, B 2 by 3 and C 3 by 4 and D 1 by 4. So we know that summation of pi xi is equal to x is equal to 1. We substitute all the probabilities, or we add all the probabilities. We get k plus 3k plus 5k plus 2k plus k, that is equal to 1. We get as 12k is equal to 1, which is k is equal to 1 by 12. So for now, p x greater than equal to 2, we have p x is equal to 2 plus p x is equal to 3 plus p x is equal to 4. So we substitute the value of probability of x is equal to 2, x is equal to 3 and x is equal to 4. We get as 5k plus 2k plus k. We add this, we get as 8k. We substitute the value of k, we get as 1 by 12, which is 2 by 3, which is option B. Option B is the correct answer. Question 3. Let x denote the number of hours that a bus travels in a city during a randomly selected day. The probability that x can take the value x as the following form, where k is the some unknown constant. We have probability for each probability, we have condition for x, that is for 0.1 x is equal to 0. For k into x is x is equal to 1 or 2. For k 5 minus 1, 5 minus x is equal to 3 or 4. For 0 otherwise. Then the value of k is, we have four options: A 0.35, B 0.3, C 0.15 and D 0.2. We make a PDF, that is probability distribution, that is x and p of x. We get 0, 1, 2, 3 and 4. 0.1, k, 2k, 2k and k. We add all this probability, which is the probability distribution. The sum of all the probabilities in probability distribution is always unity. So we get px is equal to 0 plus of p x is equal to 1 plus of p x is equal to 2 plus of p x is equal to 3. So p x is equal to 4 equal to 1. We substitute the values: 0.1 plus k plus 2k plus 2k plus k is equal to 1. 6k is equal to 0.9. K is equal to 0.50, which is option C. Option C is the correct answer. Question 4. Let x be a random variable which assumes values x1, x2, x3, x4 such that 2p x is equal to x is equal to 3p, x is equal to x2 equal to p x is equal to x3 is equal to 5p into x is equal to x4. Then the probability distribution of x is, we have four options with probabilities. We solve. Let p x is equal to x3 equal to k, then px is equal to x1 k by 2, comma for px is equal to x2 k by 3, px is equal to x4 k by 5. Adding all this probability distribution, we get unity, that is px is equal to x1 plus px is equal to x2 plus px is equal to x3 plus of px is equal to x4 equal to 1, which we get as k by 2 plus k by 3 plus of k plus k by 5 equal to 1, which is k is equal to 30 by 61. So if we substitute the value of k in every probability, if we check 30 by 61 as in option A, so the option A is a correct answer. Question 5. A random variable x takes the value of 0, 1, 2 and 3 such that p x is equal to 0 equal to p x greater than 0 equal to p x less than 0, p x is equal to minus 3 equal to p x is equal to minus 2 equal to p x is equal to minus 1, p x is equal to 1 equal to p x is equal to 2 equal to p x is equal to 3. Then the probability distribution of x is, we have 4 options, so we let p x is equal to 0 equal to be k, given that p x is equal to 0 equal to p x is greater than 0, p x is less than 0. Therefore p x is equal to 0, x greater than 0 equal to k, and p x less than 0 is equal to k, which is p x is equal to 0. We add all this, which is probability distribution, sum of probability distribution is unity, so we get p x is equal to 0 plus of p x is equal to x greater than 0, p x is less than 0 equal to 1. We add, we substitute the value, we get 3k is equal to 1, which is k is equal to 1 by 3. Now p x is less than 0, which is equal to k. Therefore p x is equal to minus 1. We know that less than 0 we get negative numbers, integers, so p x is equal to minus 1 plus p x is equal to minus 2 plus p x is equal to minus 3, which is equal to k. We add this, we get as 3p x is equal to minus 1 of k. So p x is equal to minus 1 equal to p x is equal to minus 2 equal to p x is equal to minus 3, which is equal to k upon 3, that is 1 upon 9. We substitute the value of k, that is 1 by 3 in it. So when similarly we can say for p x is greater than 0 equal to k can be written as p x is equal to 1 equal to p x is equal to 2 equal to p x is equal to 3, which is equal to 1 by 9. So we match the values with the option, which we get D. So D is the correct answer. Question 6. A bag contains 4 red and 6 black balls. 3 balls are drawn at random. Then the probability distribution of the number of red balls is. We have 4 options with X and probability. We start. Let X denote the number of red balls from the bag. There are 4 red balls. X can take value of 0, 1, 2 and 3. So we use combination formula in this. For P, X is equal to 0, which is probability of getting no red ball, 6 C3 to 10 C3 is equal to 1 by 6. For P, X is equal to 1, where probability of getting one red ball, so we solve 4 to C1, 6 C2, 10 C3 equal to 1 by 2. For p x is equal to 2, probability of getting 2 red balls, we get 4c2 into 6c1 10c3, which is equal to 3 by 10. For p x is equal to 3, probability of getting 3 red balls, 4c3 10c3, that is equal to 1 by 30. So which is option B. Option B is the correct answer. Question 7. Following as a probability distribution, we have x0, 1, 2, 3, 4. For 0, we have 0.1, that is probability. For 1, we have 0.2. For 2, we have 0.3. For 3, we have 0.15. And for 4, we have 0.25. So then the cumulative distribution function is, we have options with function fx and x. We know that for cumulative distribution function, fx is equal to p of x less than equal to xi, that is p1, p2, p3 plus of pi, where I is equal to 1, 2, n. So we can solve with the function f x1 first, that is equal to p1 0.1, f of x2, which is equal to p1 plus of p2 0.1 plus of 0.2 is equal to 0.3. For f of x3 is equal to p1 plus p2 plus of p3 equal to 0.1 plus 0.2 plus of 0.3, which is equal to 0.6. For fx4, we add all the probability, we get the value of 0.75. For fx5, we add all the probability, we get 1, which we compare all this value in option, which we have 0.1 for 0, 0.3 for 1, 0.6 for 2, 0.75 for 4, and 0.4 for 1. So therefore option A is the correct answer. Question 8. A random variable x has the following probability distribution. We have given table with x and probability. The value of p is, we have 4 options: a minus 1, b 1 by 10, c minus 1 by 10, and d none of this. We know that summation of px is equal to 1, that is unity. So we add all the probabilities, that is 0 plus p plus 2p plus 2p plus of 3p, p square plus 2p square plus of 7p square plus of p equal to 1, which we get as 10p square plus of 9p minus of 1 is equal to 0. So we get a quadratic equation, we solve, we get p plus of 1, 10p minus of 1 equal to 0. So we get p is equal to 1 by 10. Since p is greater than equal to 0, that is, therefore p plus of 1 is not equal to 0, which we get p is equal to minus 1. So therefore 1 by 10 is a correct answer, that is option B. Question 9. A pair of dice is thrown and x denotes the sum of numbers on them, then the expected value of x is. We have 4 options, that is a ex is equal to 2, b ex is equal to 6, c ex is equal to 7, and d ex is equal to 8. In a single throw of a pair of a dice, the sum of the numbers on them can be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So x can take value of 2, 3, 4 and 12. The probability of distribution of x, that is 2, 3, 4 till 12. The probability of distribution of x can be, we have to make a table, that is x 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So we get probability of px as 1 by 36.
Last question.
For 2 is 2 by 36. For 4 is 4 by 36. For 5 by 36. So similarly we get 6 by 36, 7 by 36, still 12 by 36. So for expected value, for formula is x is equal to I, no, sorry, that is I is equal to 1 to n, that is xi pn. So we multiply the x value and the probability value, and we take the summation of xi pn. So 1 by 36 into 2 plus of 2 by 36 into 2, 3 plus 3 by 36 into 4 plus of 4 by 36 into 5. So similarly we add all the probabilities, we get as e raised to x 1 by 36, that is 2 plus 6 plus 12 plus 20 plus of 30 plus of 42 plus of 40 plus of 36 plus of 30 plus of 22 plus of 12. So we add this, we get 252 by 36, we get as 7, which is C option. Please note that for 3 is 2 by 36, and for 4 is 3 by 36, and for 5 it's 4 by 36, and for 6 it is 5 by 36, and for 7 it is 6 by 36. So according to that, the sum and the values changes. So we get option C as a correct answer. Question 10. If a coin is tossed twice and x is the number of tails, then expected value ex, that is equal to a0, b1, c2, or d none of this. X can take the values of 0, 1 and 2. So we take probability as x is equal to 0, that is probability of not getting tails, that is 1 by 4. Probability for x is equal to 1, that is probability of getting one tail, that is half. P x is equal to 2, probability of getting two tails is 1 by 4. And for expected value, that is 0, 1 by 4 plus 1 into half plus of 2, 1 by 4 equal to 0 plus of half plus of half, which is equal to 1, which is option B. Option B is the correct answer. Question 11. If the probability mass function of a discrete random variable x is px is equal to c by x raised to 3, where x is equal to 1, 2, 3 or 0, that is otherwise, then e x, that is expected value, is 343 upon 297, that is option A. B 294 upon 251, C 297 upon 294, D 251 upon 294. We have P1 C upon 1 cube. We substitute the value of x. We have P2, that is C upon 2 cube. We have P3, that is equal to C upon 3 cube. So we have P1 plus of P2 plus of P3, that is equal to 1. So we substitute the value of probability, that is C upon 1 plus C upon 2 cube plus C upon 3 cube. So we solve this, we get 1 by 1 plus 1 by 8 plus 1 by 27 equal to 1. That is 216. We take LCM and we solve that. 27 upon 8, 216 equal to 1, which is C is equal to 216 upon 251, which is option. Sorry, further we solve for expected value, that is ex. We got the value of C, we can substitute the value of C. 1 C upon 1 cube plus of 2 C of 2 cube plus of 3 C upon 3 cube. So we get C1 plus of 1 by 4 plus of 1 by 9, which is equal to C of 36, 9 plus 4 upon 36. So we solve this, we multiply with C, we substitute the value of C, that is 216, 251 into 49 upon 36, which is equal to 294 upon 251, which is option B. Option B is the correct answer. Question 12. In a game, a person is paid rupees 5 if he gets all heads or all tails. When 3 coins are tossed, he will pay rupees 3. If either 1 or 2 heads appear, then the expected amount to win the game is A1, B5, C minus 5 and D minus 1. Let X be the amount he got. Then X can take the value, that is 5 and minus 3. For probability of X is equal to 5, that is probability of getting all heads or all tails when 3 coins are tossed, that is 2 by 8, which is 1 by 4. For probability of X is equal to minus 3, that is probability of getting 1 or 2 heads, that is 6 by 8, which is 3 by 4. So the expected value can be, it is as 5 upon 1 by 4 minus of 3 to 3 by 4, which is equal to minus 1, which is option D. Option D is the correct answer. Question 13. The probability distribution of the random variable X is given by, we have X 1, 2, 3, 4 and the probability, that is 1 by 8 for 1, for 2 for 1 by 2, for 3 1 by 8 and for 4 is 1 by 4. Then the value of Vx is equal to, we start with expected value that we know as summation of xi into p of xi. We substitute all the values and take the sum of all. So we solve this, we get 5 by 2. We substitute the value of 5 of expected value and variance, that is v. So we know that Vx is equal to e of x the whole square minus of e of x square, that is summation of xi square into p of xi minus of 5 by 2 the whole square. We solve this, we substitute all the values, that is 1 by 8 1 the whole square plus 1 by 2 2 the whole square plus 1 by 8 3 the whole square plus 1 by 4 4 the whole square minus of 25 by 4, which is 5 by 2 is 25 by 4. So we solve this, we take LCM, we get 58 minus of 550 upon 8, which is equal to 8 by 8, which is equal to 1, which is option 1. Option B is the correct answer. Question 14. The mean and the variance of heads in 3 tosses of a coin are: A mean is equal to 1.5, variance is equal to 3 by 4, B mean is equal to 1.75, variance is equal to 3 by 2, C mean is equal to 16.5, variance is equal to 3 by 16, where D mean is equal to 1.8, variance is equal to 3 by 5. Let X denotes the number of heads in 3 tosses of a coin, where X can take the values of 0, 1, 2 and 3. So for probability, that is X is equal to 0, which is probability of getting no heads, that is P of T and T is equal to 1 by 8. For probability X is equal to 1 of getting one head, that is P H T H T T T H T. Please note that it is, which is HHT is T TTH. So we get 3 by 8. For P, X is equal to 2, that is for probability of getting 2 heads, that is P of HHT, HTH, THH, which is equal to 3 by 8. x is equal to 3 for probability of getting 3 heads are p of h, h and h, which is equal to 1 by 8. So for mean, we have summation of xi pi, which is 0 into 1 by 8 plus 1 into 3 by 8 plus 2 into 3 by 8 plus 3 into 1 by 8, which is equal to 1.5. So we make a distribution table, that is xi pi xi square. We get 0 1 2 and 3. For pi is 1 by 8 and for pi into xi is 0, and for this is also 0. So for 1 is 3 by 8 pi, so we multiply this, we get 3 by 8. Even this is 3 by 8. For 2 is 3 by 8, we multiply, we get 6 by 8. This we get 12 by 8. For 3 is 1 by 8. 3 is 3 by 8, and for pi xi square is 9 by 8. We add pi xi, that is we need summation of pi xi, we get 1.5, and for summation of pi xi square we get 3. So for variance, e of x square minus of e of x the whole square, which is we got e of x square as 3, and for e of x the whole square we got 1.5, that is whole square, which we get as 0.75, which is option. Therefore we check the mean value which we got is 1.5, which is option A. So therefore variance also will be 3 by 4, that is when we divide 3 by 4 we get 0.75. So option A is a correct answer. Question 15. A random variable x takes the value of 1, 2, 3, 4 with probabilities 1 by 6, 1 by 3, 1 by 3 and 1 by 6 respectively. Then its mean and variance is equal to A 5 by 2, 11 by 2, B 5 by 2, 11 by 16, C 5 by 3, 11 by 16 and D 5 by 3, 11 by 12. So for me, expected value, that is summation of xi, p of xi, we substitute all the values, 1 by 6 into 1 plus of 1 by 3 into 2 plus 1 by 3 to 3 plus of 1 by 6 into 4. We solve this, we take LCM, that is 1 plus 4 plus 6 plus 4, we get upon 6, which is equal to 15 by 6, which is equal to 5 by 2. For the variance, summation of xi the whole square, p of xi minus of p x the whole square. We substitute the values. We solve this, we get as, taking NCM and all, we get as 86 minus of 75 by 12, which is equal to 11 by 2, which is option A. Option A is the correct answer. Question 16. The random variable x has the following probability distribution, where x is minus 3, minus 1, 0 and 1 and 3. For p, x is equal to x, which is minus 3 of 0.05, minus 1, 0.45, for 0 it is 0.20, for 1 is 0.25 and for 3 is 0.05. Then its mean is A minus 0.2, B 0.2, C minus 0.4 and D 0.4. For mean, that is equal to expected value Ex, summation of xi into pi of xi. So we substitute the value of xi and pi, pxi, we get 0.053 plus of 0.45 minus of 1 plus of 0.20 into 0 plus of 0.25 into 1 plus of 0.05 into 3, which we get as minus 0.15 minus of 0.45 plus of 0 plus of 0.25 plus of 0.15, which is equal to minus 0.2, which is option A. Option A is the correct answer. Question 17. For a random variable x, if expected value is equal to 5 and the variance that the Vx is equal to 6, then Ex square is equal to A 19, B 31, C 61 and D 11. We know that expected value Ex is equal to 5 and Vx is equal to 6. So for variance Vx we have formula that is Ex the whole square minus of Ex the whole square. So we substitute the value of Ex and Vx, we get Cx is equal to Ex square minus of 5 the whole square. We solve it, that we get as Ex square, that is 25 plus 6, which is equal to 31, which is option B. Option B is the correct answer. Question 18. The probability of distribution of random variable x is given by, we have a given table that is x 0, 1, 2, 3, 5, 1, 3, 5, and for x is equal to x, that is probability. For 0 is 0.2, 1 is 0.5, 3 is 0.2 and 5 is 0.2. Then for 4 Ex the whole square minus of V variance of x is equal to A 2.24, B 19.2, C 16 by 96 and D none of this. We have expected value summation of xi, E of xi equal to 1.6. After adding all the probability, the summation of probability for variance of x, that is equal to summation of xi square into P of xi minus of E of x the whole square. We substitute all the value, we get 4.8 minus of 2.56, which is equal to 2.24. Now for the given equation, that is 4 of Ex square minus of variance of x, which is equal to 4 summation of xi square P of xi, that is minus of variance x, which is equal to 4.8 minus of 2.24, which is equal to 19.2 minus of 2.24, which is equal to 16.96, which is C. Option C is the correct answer. Question 19. The probability of a continuous random variable x as fx is equal to k by root x, which is x is greater than 0 and which is less than 4. For 0 it is otherwise. Then p x is greater than equal to 1 is equal to a 0.2, b 0.3, c 0.4 and d 0.5. So we have for CRV, that is continuous random variable, for condition for that we have minus infinity to infinity fx dx is equal to 1. So we have the equation of fx, so we substitute that, and for limit, that is 0 to 4, k upon root x dx is equal to 1. We k, that is we integrate 1 upon root x, we get 2 root x 0 to 4 equal to 1, which is 2k. We substitute the value of x, that is we substitute the value of limits in x, we get root 4 minus of root 0, which is equal to 1. We solve for k, we get k is equal to 1 by 4. We have p x greater than equal to 1, that is p1 is x which is greater than equal to 1 and less than 4. So for summation 1 to 4 of fx dx is equal to 2k, we substitute the value of k in that, we get 1 to 4. We substitute the value of k, that we got 1 by 4, and substitute the value of limits in x, we get 2 minus 1. We solve this, we get half, which is 0.5, which is option D. Option D is a correct answer. Question 20. If the probability density function of a continuous random variable is fx is equal to 3 plus 2x upon 18, 2 less, which is x is greater than equal to 2 and less than equal to 4, equal to 0, otherwise, then the mathematical expectation of x is, we have option A 83 by 27, B 27 by 83, C 27 by 23 and D 38 by 72. We have expected value with the continuous random variable, that is minus infinity to infinity x fx dx. We substitute the value of fx, that is 3 plus 2x upon 18, and even the limits, that is 2 to 4, that is x 3 plus of 2x 18 dx. We take 18 outside, we get 2 to 4 integral of 3x plus of 2x square dx. We integrate, we get 1 by 18 3x square by 2 plus of 2x cube by 3, 2 to 4. We substitute the value of limits in x, we get 1 by 18 24 plus of 128 by 3 minus of 6 plus of 16 by 3, 1 by 18 into 166 by 3, which is equal to 83 by 27, which is option A. Option A is a correct answer. Question 21. If probability distribution function of a continuous random variable is fx is equal to a into e raised to minus ax, x is greater than equal to 0, a greater than 0, equal to 0, otherwise, if p has x is greater than 0 and less than equal to k, which is equal to 0.5, then k is equal to, we have 4 options, that is a half log a, b 1 by a log 2, c 1 by 2 log 2 and d 1 by a log a. So we have 0 which is less than equal to x less than equal to k, that is 0.5, which is integrate, we substitute, we have 0 to k, function of fx dx is equal to half. We substitute the value of fx, we get a raised to minus eax dx is equal to half. We integrate, we get e raised to minus a x upon minus of a 0 to k, which is equal to half. Solve this, a get cancelled, we left with only minus e raised to minus ax, that is 0 to k equal to half. We solve, we get e raised to minus ak, that is we substitute the limits in the x, we get e raised to minus ak, e raised to 0 is equal to half, we get e raised to minus ak plus of 1, that is e raised to 0 is 1. ak is equal to half. We take anti-log, we get minus of ak is equal to log of half. We solve this further, we get log k is equal to log 2, that is, which is k is equal to 1 by a log 2, which is option B. Option B is a correct answer. Question 22. X is a continuous random variable with probability density function, that is fx equal to x square by 8, where x is greater than equal to 0 and x is less than equal to 1. Then the value of p, that is x is greater than equal to 0.2 and less than equal to 0.5 is a 0.117 upon 24, b 0.112 upon 24, c 0.113 upon 36 and d 0.112 upon 36. So we have the condition, that is p of 0.2 less than equal to x, which is less than equal to 0.5. we integrate from point 1, point 2 to point 5, that is x square upon 8 dx. We integrate, we get as x cube 8 into 3, that is point 2 to point 3, this is equal to 1 by 24, 0.5 cube minus of 0.2 cube. We solve this, we get 0.125 minus of 0.008 upon 24, which is equal to 0.117 upon 24, which is option A. Option A is the correct answer. Question 23. Following is the probability density function. Fx is equal to k into x into e raised to minus 4x square, where x is greater than or equal to 0 and less than or equal to infinity. Then the value of k is, we have four options: A 8, B 5, C 7 and D minus 1. So we have, for density function we have 0 to infinity of fx dx is equal to 1. So we substitute the value of fx, we get 0 to infinity k x e raised to minus 4x square dx is equal to 1. We solve this, we take k outside, we integrate e raised to minus 4x square, we get as 2 of e minus 4x square upon minus of 4, that is 0 to infinity, which is equal to 1. We solve this, we get minus k upon 8 minus e raised to 4x square, 0 to infinity equal to 1. We get minus k upon 8, 1 upon infinity, 1 upon 1, which is equal to 1. We get k is equal to 8 equal to 1, which in turns to k is equal to 8, which is option A. Option A is the correct answer. Question 24. If A and B are two independent events, then A and B bar are, we have four options: A not independent, B also independent, C mutually exclusive and D none of this. Since A intersection of B bar and A intersection of B are mutually exclusive events such that A is equal to A intersection of B bar union of A intersection B. Therefore, probability of A is equal to probability of A intersection B bar plus of probability of A intersection B, that is probability of A intersection of B bar equal to probability of A minus of probability of A intersection B, which is equal to probability of A minus of probability of A probability of B. Since we see that A and B are independent, so therefore for P, probability of A intersection B bar equal to probability of A minus 1 probability of B, which is equal to probability of A into probability of B. So A and B bar are also independent. This is B bar. So therefore A and B are also independent. So therefore answer B is the correct answer. Question 25. A card is drawn at random from a pack of 52 cards. The probability that the drawn card is a court card, that is a jack, a queen or a king, is, we have four options: A 3 by 52, B 3 by 13, C 4 by 13 and D none of this. Total number of cards which we have in a pack of cards, that is 52. Chances of getting spade is equal to 13 by 52, which is equal to 1 by 4, and chances of not getting spared is equal to 1 minus 1 by 4, that is 3 by 4. So chances that the person will not get spade in the first two draws, that is 3 into 4 into 3 into 4, that is equal to 9 by 16. which is, if we see, compare with the option, there's no option like 9 by 16. So D is the answer, that is none of this. Question 26. A man and a woman appear in an interview for two vacancies in most posts. The probability of man's selection is 1 by 4 and that of women's selection is 1 by 3. What is the probability that none of them will be selected? A half, B 1 by 12, C 1 by 4, or D none of this. Let E1 be the event that the man will be selected and E2 be the event that woman will be selected. Then probability of E1 is equal to 1 by 4. So probability of E1 bar is equal to 1 minus of 1 by 4, that is 3 by 4. And probability of event 2 is 1 by 3. So the probability of E2 bar is equal to 2 by 3. Clearly E1 and E2 are independent of events. So probability of E1 bar intersection of probability of E2 bar is equal to probability of E1 into probability of E2 bar, which is equal to 3 by 4 into 2 by 3, which is equal to half, which is our option A. So therefore option A is a correct answer. Question 27. A box containing 4 white pens and 2 black pens, another box containing 3 white pens and 5 black pens. If one pen is selected from each box, then the probability that both the pens are white is equal to, we have 4 options, A half, B 1 by 3, C 1 by 4, and D 1 by 5. So total number of pens in first bag is equal to 4 plus 2 is equal to 6, and the total number of pens in the second bag is equal to 3 plus 5, which is equal to 8. The probability of selecting the white pen from the first bag, white pen from first bag, is equal to 4 by 6, that is equal to 2 by 3, and the probability of selecting white pen from second bag, which is equal to 3 by 8. So the required probability that both the pens are white is 2 by 3 into 3 by 8, which is equal to 1 by 4, which is option C. Option C is the correct answer. Question 28. A bag contains 3 black and 4 white balls. 2 balls are drawn one by one at random without replacement. The probability that the second drawn ball is white is, we have 4 options, A 4 by 49, B 1 by 7, C 4 by 7, and D 12 by 49. Your second white ball can be drawn in two ways. That is, first is white and the second is white. So probability we get as 4 by 7, 3 by 6, that is 2 by 7. For second one, that is first is black and second is white. Therefore probability we have 3 by 7, 4 by 6, which we get as 2 by 7. So the required probability, we can write it as 2 by 7 plus of 2 by 7, which is equal to 4 by 7. So option C is a correct answer. Question 29. A and B are two independent events such that probability of A is half, probability of B is 1 by 3. Then P, neither A nor B is equal to A 2 by 3, B 1 by 6, C 5 by 6, and D 1 by 3. we have probability of neither A nor B, which is equal to probability of A bar intersection of B bar, which is equal to P of A bar into P of B bar. So for probability of A bar, which is equal to 1 minus of probability of A, equal to 1 minus of half, which is equal to half. Probability of B bar is equal to 1 minus of probability of B, which is equal to 1 minus 1 by 3, which is equal to 2 by 3. So therefore for probability of A bar into probability of B bar is equal to 1 by 2 into 2 by 3, which is equal to 1 by 3, which is our option D. So therefore option D is the correct answer. Question 30. The probability of throwing 16 in one throw with 3 dice is A 1 by 36, B 1 by 18, C 1 by 72 and D 1 by 9. The total number of favorable ways can be given as n of E, that is 6 comma 6 comma 4, that is we get 16, 6 comma 4 comma 6, same way 4 comma 6 comma 6, 5 comma 5 comma 6, 5 comma 6 comma 5, 6 comma 5 comma 5, that is equal to 6. So the total number of ways that is n of s is equal to 6 into 6 into 6, which is equal to 216. So the required probability is equal to n by n of E upon n of s is equal to 6 by 216, which is equal to 1 by 36, which is option A. Therefore option A is the correct answer.